Good evening, everybody. Thanks, Karen. We appreciate that. Thanks to all of you for coming out. When I became the director of the Dole Institute back in fall of 2004, one of the things I immediately wanted to work on was building a student culture, really creating great opportunities for KU students to interact with political leaders, with journalists, with practitioners on political and policy issues. Tonight's program is part of the outgrowth of that effort. It was conceived, designed, and is being conducted by the Dole Institute Student Advisory Board. And as Karen just said, Dole Institute Student Advisory Board members get all kinds of wonderful opportunities. So if you're a KU student, if you're interested in joining, that's all you have to do is join and come to the meetings, and you can talk to Andrew or any of our Student Advisory Board members here tonight about membership in our Student Advisory Board and all the wonderful opportunities you receive from that. Tonight's program is a pro-con discussion of hydraulic fracturing, or fracking. Our co-sponsors tonight are the KU Association of Water and Environment and the KU Energy Club. We have two very special guests tonight representing two very distinct points of view. Please read their very impressive biographies on your program. Our guests are Mr. Edward Cross of the Kansas Independent Oil and Gas Association, and representing the Sierra Club of Kansas, Mr. Joe Spease. Please join me now in welcoming them to the Dole Institute. Our guests will be questioned by two students, Student Advisory Board Coordinator Andrew Toth and Mr. Miles McGonigal. Before we turn the program over to Andrew, Mr. Matt Fowler of the KU Energy Club is going to do a brief overview of fracking. Please welcome Matt. Matt?
Thank you, Bill. Well, to start tonight's event, I would like to provide a broad and general overview of the hydraulic fracturing process. We did have a wonderful animation to help illustrate this process, but since our technical difficulties, we will do without. A temporary drilling rig called an oil derrick is used to drill a vertical well that goes several thousand feet deep beneath the Earth's crust. Once the drill reaches the shale formation, it will then turn horizontal. The drill is then removed, and then a well casing is inserted into the well. Once the casing is in place, cement is pumped into the well around the casing, forming a protective barrier of the well. This process of pumping the cement down to the well is called cementing. A drill bit will then further extend the well horizontally out several thousand feet. This secondary horizontal well is then cemented again. After this process has been completed, a perforating gun will go down into the well, and explosions will pierce through the steel casing and the cement barrier into the shale formation. A mixture of water and additives, including sand and lubricants, is then injected into the shale fractures, where natural pressure will force the liquids back through the pipe to the surface. Then natural gas will flow from the fractures in the shale formation into the wellbore. As the fluid recedes, sand grains or ceramic pellets will remain in the fractures, holding them open, so that pressurized gas can escape and rise through the well. Now, this is a very general explanation of hydraulic fracturing. It is much more complicated than this. But at this point, I would like to turn it back over to Andrew.
Thanks, Matt. I would like to start off with a question for both of you. Answer as you deem, in the order that you deem necessary or appropriate. How long has hydraulic fracturing been going on in the U.S., and why is it just now getting so much public attention?
Well, I'm glad you phrased it that way. Hydraulic fracturing comes in two different versions. There is a version that started in about 1947 in Kansas that is a vertical version that doesn't use as much water, doesn't use as much pressure, doesn't rely on the extensive different chemicals that are used in the other version, which is really a new technology. They started experimenting with the horizontal version, not just the vertical version, in the late 80s, but it really didn't take off until the gas industry was successful in getting exemptions from things like the Clean Water Act, Clean Air Act, Safe Drinking Water Act, the Superfund, and other things in 2005 that were part of the Energy Policy Act. As soon as those exemptions were in place so that certain responsibilities for any problems were removed, then things really took off. And from 2005 to 2010, we saw the most gas drilling wells in the history of the country.
Okay, I would respond to that to say that he was right in saying that the first frac job ever done in the United States was in Kansas in 1947. It is the same technology in the vertical wells as it is in the horizontal wells. What is the new is the innovation in the technology. The multi-stage fracs in the horizontal section of the wells is an innovation in an existing technology that's been used since 1947. Actually, the hydraulic fracturing industry has never been exempted from any regulations of hydraulic fracturing, even in 2005. 2005, what they did is they made hydraulic fracturing that used diesel in it, subject to the Safe Drinking Water Act, and left the exemptions that were from the Safe Drinking Water Act in place. Those exemptions that we talk about in the Safe Drinking Water Act were put in place in 1974, I believe, and those were there because what they did is when they put those regulations in, they took into account existing state statutes that were already in place. For example, the Kansas Corporation Commission first began in 1935, and the U.S. EPA began in 1974. So many state organizations, state regulatory agencies like Kansas Corporation Commission already had a lot of state statutes that regulated hydraulic fracturing, and so they took those distinctions into consideration whenever they made the Safe Drinking Water Act. And so that technology has been around for a long time, and indeed horizontal drilling started in probably the early 80s and took off in the 90s. And it's a technology that has also been innovated through the years, just like the hydraulic fracturing.
All right, moving on then. Are there currently alternatives to hydraulic fracturing for removing natural gas? And if so, are they currently being used?
I'll start with that one. Yeah, you know, hydraulic fracturing is a stimulation process in wells, and many times it's used in wells. In the horizontal wells, for example, it's used in formations that are very tight, and when we say tight, I mean low porosity and permeability. So what they do is they take advantage of the natural fractures that are in the rock. And whenever you pump water and sand into the rock, that sand goes into these natural fractures and opens those fractures up. The pressure holds the sand in there. And then when they get done fracking, the sand has wedged those fractures open so the oil and natural gas can flow to the wellbore. So that is a process that's been used, like I said, for over 65 years in formations that have very low permeability and porosity.
The thing that we're trying to encourage is to get away from the use of so many of the toxic chemicals that are involved in the process. And the industry now is exploring different types of fluids that will accomplish the different purposes that those chemicals serve currently in that process. We think that would be great. What we also believe is just getting completely away from fossil fuels altogether is an idea that has merit. And the possibilities for things like renewable hydrogen that are made with wind power at night and wastewater and electrolysis are options that we believe have great potential and eliminate all the risk and problems with contamination.
Now, do either of you see natural gas as a long-term solution to the energy needs in the U.S.?
I don't, not at all. There are several problems here. First of all, when you're fracking a well, I'm not, you correct me on the averages here, Ed, but I believe that it's in the neighborhood of 80% of the production, the effective production from one of these fracking exercises is gone within the first 2 years. Then when it becomes uneconomical, the drillers already start thinking of the next spot. This is going to create these booms and busts all over the place because of the rapid depletion of a product available from one fracking event. we think there might be some advantage in the short term until we've been able to effectively create energy storage and renewable hydrogen production that will make all of those needs unnecessary.
Yeah, one of the things I'd point out is that today fossil fuels account for about 83% of our energy supply, and the Energy Information Administration would come out and say that fossil fuels will still comprise about 80% in the year 2035. If you look at natural gas production in the United States, our production has gone up significantly so that we have 6 times as much natural gas today as we did a decade ago. So if we measure our natural gas reserves now in centuries. It's also true with crude oil. Crude oil, there's been over 20 new onshore oil fields found in the United States that could significantly increase our supply and increase our energy security in this nation, maybe as much as 25% over the next decade. So the oil and natural gas reserves are going to be an important part. When you look at going out into the future, I think the Energy Information Administration projects that the world's going to need 45% more energy by the year 2035, 16% more energy in the United States. So we need more energy of all types, and we can't stay trapped by these zero-sum games that say that we have to have less oil and natural gas so that we can have more of something else. I think we need all energy sources, and oil and natural gas are a very important part of our energy mix in the future.
I want to add one other thing, too. There's an article that came out in the March issue of Rolling Stone magazine called The Fracking Bubble, and it includes information about conflicting estimates of just exactly how much potential there is in shale gas around the country. These have been revised downward from the estimates that the gas industry produced from around the year 2000. And their estimates now, if you look at what might be possible throughout the country, some of those estimates now are as low as 23 years. So it could be that we'll have no choice but to start exploring other options than shale gas very soon.
Okay. From the research that I conducted before this event, companies don't usually disclose the chemicals used in the fracturing fluids. Can either of you speak to why there are concerns about this, and maybe on the topic of what is the chemicals of concern?
I can begin this one. I know Kansas Independent Oil and Gas Association, the group that I lead, is made up of about 1,400 members. We are small independent oil and gas producers. And one of the things that we always encourage our members to do is disclose frac fluids. We're not opposed to transparency. We are supportive of what's in the frac fluids. Many times, I know many companies, as an independent producers, what we do is we hire companies who provide a frac service, a hydraulic fracturing service. And they'll come out and they'll do the fracturing job for us and then report what's in that chemical so that they have it on location and material safety data sheets. Some of the proprietary information that some of those companies may have sometimes is something like I would always describe as you have your grandma's favorite chocolate chip cookies, and most of us may be able to figure what's probably most of the ingredients in a chocolate chip cookie. But my grandma's chocolate chip cookies may be different than your grandma's chocolate chip cookies, and it's because of the way that they put it together. And and she wants to keep that a secret. And so what companies do, they'll have proprietary information, and many times what they'll do is they'll have that information. All that information, by the way, is required to be on site with material safety data sheets. But what they'll do is they'll disclose that to the landowner on which the well is located, or an adjacent landowner, or a state agency that needs that, or in the case of an emergency, certainly a healthcare individual that would be on site there that would need that information. So.
Well, this goes right to the heart of one of the biggest problems that environmentalists have with hydraulic fracturing. They're not required to provide and disclose the full list of chemicals that are used in this process. And if you look at the different geologic formations, there are several primary formations around the country. You have the Marcellus Shale Formation that is underneath some of the mid-Atlantic states. You have the Barnett Shale in Texas. You have the Haynesville Shale. It's in Louisiana and Arkansas, and then in Kansas you have the Niobrara up in the northwest corner, the Mississippian line that's in the central part of the state, and some others that are down in the southeastern part of the state. They all vary a little bit in their geology, and because they vary, the gas companies have to use different combinations of chemicals to effectively extract the natural gas. And because these formations differ, the gas industry believes it's necessary to keep some of their chemicals used in the process secret. They're proprietary, and they believe that to divulge those would compromise their business. What we're suggesting is that there is a way of providing the complete list, and it's over 1,000 different chemicals, or at least something close to 1,000 different chemicals that are used in this process. All we ask is that we create some entity, in Kansas case would be, the logical one would be the Kansas Corporation Commission, who would manage the handling of any of the chemicals that are considered proprietary, but they still have to be disclosed. If a first responder goes to a site, and believe me, there have been explosions in fracking, there have been all kinds of problems in several states around the country. And when first responders show up at this site, if they look at the MSDS sheets, they're going to be disappointed because most of the chemicals here don't have their CAS numbers as assigned by the American Chemical Society. That won't give first responders the information they need to effectively manage any problems as a result of these explosions or blowouts or the other things that are happening at these sites. So we think it is of critical importance to require full disclosure of these chemicals. It can be done to protect the business and still provide adequate treatment at the sites in the event of an emergency.
I might add to that I don't know of any explosions or anything at well sites because of hydraulic fracturing. And you know, one of the things that we do is that Frac Focus is a website, fracfocus.org, put together by the Groundwater Protection Council, Interstate Oil and Gas Compact Commission. And we encourage all of our members to report their chemicals disclosures to this website, which is a public website that they put that on there. And what you'll find when you go on there is that almost always 99 to 99.5% will be sand and water, with the other chemicals also listed on that. And as far as explosions and things like that at wells, I've been in the oil and gas industry over 26 years as a geologist. I've helped design many of these frac jobs. I work with my other colleagues in other states, and I don't know of anything like that.
I can help you out with that, Ed. I met with executives from Chesapeake. Chesapeake is one of the very largest fracking companies, and I met with a team of their top executives, and we talked about the explosion they had at one of their wells in Pennsylvania. It was a massive explosion and sent tens of thousands of gallons of this toxic goo into the stream that flowed into Maryland, and now Chesapeake is being sued by the state of Maryland. And we had a discussion just to talk about the status of that suit. We've got photographs of another explosion in Silt, Colorado that required several families. They had to evacuate their homes. There have been others in Texas. It does happen. There are blowouts, there are explosions. When you're dealing with this process and with such high pressures, up to 16,000 psi, that's a huge amount of pressure. It's just inevitable that you're going to have failures of some kind or another, whether it's with the well casing because of the combinations of these chemicals reacting with other things underground. There are any number of things that can happen that make this a very dangerous process, and it's happening, and we're seeing the contamination that results from it.
Now, I would think that the Chesapeake case and many of the others, whenever we talk about hydraulic fracturing, we're talking about the actual process of fracking, like he described, the shale or the Mississippian lime or other formation, sand, with the sand and water that we're pumping down hole. Whenever you have above ground spills or other connections on the surface, those are regulated by other waste management and other regulations, and are really not associated with hydraulic fracturing, but are associated with waste management or some other issues. So sometimes I think the whole realm of hydraulic fracturing is expanded in scope to include things that are not related to hydraulic fracturing. And so when you just look at hydraulic fracturing itself, you'll see that there's not been any cases like that.
Okay. What kind of permits does a company have to attain before they begin to frack, and is this enough to prevent damage to the environment and public health in general?
Well, why don't you go ahead and...
Okay, like I say, the service companies that actually provide the fracturing job, like in Kansas, I represent the independent oil and gas producer. Yeah, I'm trying to think. I don't think there's one of them that do the fracks themselves. I don't think there is, but because I think there's 5 or 6 companies that do frack services. So those companies are, and they operate not only in Kansas but in a number of other states. And it requires a significant amount of capital in order to do a hydraulic fracturing job, to have the equipment on the place to do that. So you're talking, $20 million worth of equipment or something just to be able to do a frack job. And so there have a lot of people that are trained, engineers as well as other professionals out there that are able to design that frack and also get all the equipment and everything ready to do that.
This is another problem we have. The permitting process right now is just far too simple. If you compare the regulations that currently exist in Kansas to the regulations that have now changed and increased in complexity in Pennsylvania and in the other states where they've had so many problems, and this is something that we're trying to prevent in Kansas. We hope that we can learn from the experiences they've had in the other states and understand that the regulations that we're asking for aren't meant to just create complexity for the gas industry just out of a meanness that we and wacky environmentalists have. They have a very specific purpose to protect farmers especially, and water in Kansas, and air and land. And water especially right now, when you're going through the permitting process, there is an enormous amount of water used in the hydraulic fracturing process. They use Shell just did a presentation just a few days ago at the Kansas Water Issues Forum. And they said that they are using, in their fracking activities in Kansas, about 4 million gallons per fracking attempt. Now remember, as soon as that water is combined with these toxic chemicals and injected underground, and then through the fracking process, you release radiation and volatile organic compounds that combine with this water. That water is, for the most part, going to be useless. We aren't equipped in Kansas right now to eliminate, to remove those ingredients from that water once it's been mixed together. So we're taking this water out of the hydrologic cycle at a time when Kansas lost $2 billion in crops last year because of drought. In Texas, $10 billion in damage from the natural disasters related to their heat. We need to be smart about this. Is this time in history, when we're seeing these drought effects from climate change, the time when we're going to take billions of gallons of water out of the hydrologic cycle? These regulations have a purpose, and it's to protect our future for our kids.
Is the water treatable, though? I mean, what do they do with it if they take it out of the hydrologic cycle?
About 40 to 60% of it stays underground. It's just gone forever. But the stuff that flows back to the surface is also very, very difficult to treat. What they're probably going to do in Kansas, Kansas is lucky. In Pennsylvania, they don't have these injection disposal wells that we do here. In Kansas' case, they're probably just going to take it, truck it, and inject it miles. This is going down far deeper than the levels where we're fracking. It's going down much deeper yet, and then just disposed of there. In Pennsylvania, they weren't so lucky, and for the first few years, they were really just kind of dumping this stuff and running it into treatment centers that weren't equipped to even begin to have the ability to take radiation out if it was even possible, or the volatile organic compounds or any of the other toxic chemicals in the process. That water then would just flow into the drinking water systems, and the people there have been drinking it. Now, Pennsylvania, New York, and some other states, some of the communities said, we just can't do this anymore, and they put bans on it. The city of New York figured out that it would cost them $20 billion to build a water treatment facility that could even begin to handle the toxins in this water, and then an operating cost of about $1 million a day. So, and that still doesn't guarantee protection. So, it would be less expensive here in Kansas to develop something like that, but none of our cities right now is equipped to handle the toxins in this fluid. So we need to think about these things before we move too fast on this.
Oftentimes some of these anti-American energy development groups will try to scare the public with a lot of information that is confusing and requires more information for a complete discussion.
You're calling those people anti-American?
No, I didn't say that. I said anti-American energy development. I said anti-American energy development groups, not anti-American.
That's a distinction without a distinction.
Okay. Well, in Kansas, as he says, we as an industry, by the way, we also support our corporation commission. Any regulation of hydraulic fracturing be done with the Kansas Corporation Commission because we feel it's best done at the state level, and where the people who regulate the environment also live, and they can take into consideration the uniqueness of the state. I also know that last month, maybe it was in January, the American Farm Bureau Federation came out in support of oil and gas industry's use of hydraulic fracturing in a policy statement, and also suggested that any regulation of hydraulic fracturing be kept at the state level. So, farmers are supportive of that. Now, indeed, when we frack fluids, when you look at the amount of water used in a fracking, and you look at the total amount of water used for all purposes, whether it be agriculture purposes or recreation or other purposes, fracking, well, not only fracking, but all oil and gas operations use less than 1%. So, and when you look at the whole scheme of things, indeed, it's a small percent. Now, nobody's suggesting that public safety be sacrificed for fracking or anything else, because public safety always comes first for everybody. So, whenever we look at fracking fluids on that, when you look at the total fluids, they're small compared to others. Now, many of the fracks in Kansas, as you say, even in horizontal wells, was going to be somewhere in the 750,000 to 1 million gallons. Now, indeed, I haven't talked to Shell. They may have a 4 million gallon frack job that they do use. Kansas, we have a lot of vertical wells that are also fractured. The vast majority of all wells are fractured in Kansas. And they use 100,000 gallons or less. In eastern Kansas, for example, there may be 10,000 gallons or less for those. So it's a much smaller volume. Now, as far as some of the what we do with that water whenever it flows back, the water that does come back, many times much of it will be left in the formation, or it's produced back. We do inject that according to regulations, and we dispose of that into disposal wells, as he says, in formations that are often deeper than the well that the zone that was actually fractured for that. So, and we follow underground injection control regulations by the Kansas Corporation Commission in order to do that, and it's been safely done in Kansas for over 65 years. Also, on February 16th, just a few weeks ago, the Energy Institute at the University of Texas came out with a study that said that they concluded that hydraulic fracturing had no direct connection to groundwater contamination. There's been many studies of those. The EPA did one in 2004 that said this. Department of Energy's done one. The Groundwater Protection Council has done one. The Interstate Oil and Gas Compact Commission has done one. And they all concluded the same thing, that hydraulic fracturing has no direct connection to groundwater contamination. And so, the EPA is doing another study now. Congress asked the EPA to do another study of hydraulic fracturing in 2010 or something is when they started. And we as an industry agreed with that. We knew all of these studies have shown that in the past, and we knew that another study would also come out in the same way. We just urged that it be a scientifically based study. One of the things that we want to make sure is that the EPA study stays focused on what the congressional intent was, which is hydraulic fracturing, and not expanded to include things outside of hydraulic fracturing. In other words, study the environmental impacts of all oil and gas operations. That's not what the study was. So So there are many studies out there that will show that, and that it's been done safely for many years.
Okay, I have to add some things here. First, when you're comparing the water that's used in the fracking process to the water that's used for irrigation, you have to remember that water used in irrigation is part of the hydrologic cycle. It moves through the cycle effectively. We're taking this stuff out of the cycle. Now, you have to put your lawyer hat. When you hear the term no proven cases of contamination from hydraulic fracturing, the gas industry is referring to the actual fissures that are miles underground. And on the one hand, he's correct. We don't really know exactly what's going on miles underground in solid rock formations. You just can't know. When they make those little fissures, when you look at the animated versions of this, they look like cute little squiggle lines, but they're 500 to 600 feet long. We don't know exactly where they're going. But we do know that the methane and probably some of these fluids are making their way into water. What the gas industry says is you can't prove that it's coming from just the hydraulic fracturing. But if you look at the whole drilling process, we definitely know there have been proven cases of the thermogenic gas. And they like to make a distinction between biogenic gas and thermogenic gas that's making its way into the water. The biogenic gas is a result of decomposing organic matter that's in that groundwater system that's usually 50 to 300 feet below the surface. The thermogenic gas is the stuff that's created in the shale layer. We now have absolute definite proof of that thermogenic gas getting into water supplies, and it's creating serious, serious problems. Gas companies are being fined for this issue. They've been fined to Pennsylvania. And these are multi-million-dollar settlements for these problems. I don't think the gas company is going to be just throwing around lots of millions of dollars if they weren't sure that they were partly responsible. Now, they get to sign non-disclosure agreements with the people whose land is leased. So these people aren't allowed to talk about what is going on in their land. There's some people that have broken through and are talking anyway. But ProPublica has created a list of over 1,000 cases around the country in the different states where fracking is being done of people who have water problems and farmers who've seen their wells destroyed. And then they have a choice. They can either just leave. Their properties are worthless now. They can just leave. And there are several cases where that's happened, where once your well water on your land is cooked, it's contaminated, you're sunk. So it's happening, but you have to put your legal hat on and understand that when they're saying no proven cases from hydraulic fracturing, just from those fissures, in a way they're right, because we don't know exactly what's going on miles below. But the scientists are saying they have. There was a study done by Duke University, supported by the National Academy of Sciences. These aren't some wacky environmentalists out to get you. They were just doing their job, and it raised hell with Chesapeake because Aubrey McClendon, the CEO of Chesapeake, went to Duke. And so Duke University did this study in New York and Pennsylvania. They tested 68 wells, and out of the 68 wells, 51 were contaminated to hazardous levels, with contamination of methane at levels 17 times higher than any levels from wells just slightly farther away from the fracking well site. Duke University's scientists who conducted this study took their results to Chesapeake and Oklahoma City a few weeks before it was going to release and met with the science team at Chesapeake and said, here is our data. These are our conclusions. We are positive that your shale gas is making its way into the water in these wells. 51 out of 68 wells tested at random. And they said, Mr. Scientist at Chesapeake, do you have any evidence that can suggest to the contrary that what we have here is wrong? And the scientist for Chesapeake said, no, we can't. Now, when the study was released, the CEO of Chesapeake was irate and fired off a nasty letter to the chancellor of Duke University, calling these people, it was more political science than physical science, but he never challenged the science. He attacked the character of the scientists doing the work, but never really attacked the science itself. But there is a lot of science out there that says that this whole process, okay, we can't say for sure it's that little fissure, but somehow this thermogenic gas from the shale layers is making its way into water supplies, and the science is solidly behind it.
I'll add something on that. The Duke University study is something that a lot of scientists have criticized heavily. And they do that because what they looked at is several things.
Scientists or scientists funded by the gas?
Other university scientists from other universities. And what they found was this, and I'm not the scientist that did the study, but I am going to tell you that what I've learned from those studies. One is they had 68 wells, is that what you said?
Yeah.
And 51? Okay, 51, they found gas in it. Yeah, it was thermogenic gas. What they said was there are geologic reasons why that can occur. And a U.S. Geologic Survey report from over 50 years has shown that in the area where they took those samples, that there was naturally occurring thermogenic gas in those areas. So they took their sample from an area that's known to have thermogenic gas in it. So it shouldn't be surprised that maybe they found that there. They took 68 samples, and the total number of freshwater wells in that area was somewhere around 20,000. So some would say that maybe even you might question the statistical relevance of 68 samples out of 20,000. What the Duke University report actually said was that hydraulic fracturing was not the reason that those wells were contaminated with natural gas. What they said was they thought they were contaminated because of well casing failure, without any evidence of that, but that's what they said, because they had well casing failure. In the recommendations part of the Duke University report, they didn't address well casing failure. What they said needed to be done was pass a federal hydraulic fracturing regulation. So it appears that they had an agenda that with their report that they were trying to do, because they didn't really address what they said was the problem, which was well casing failure. So there's a lot of criticism of the Duke University report, all around here, but also in the nations across the ocean.
I'm going to ask one last question before we'll open it up for Q&A. We'll have mics going around, so if you have a question, just raise your hand, and a student will come to you with a mic when it's your turn. You all knocked out about the next 4 questions on our list. Thanks. Okay, you mentioned a study at UT and you mentioned a study at Duke. Are there many other or any other studies, peer-reviewed scientific studies worth mentioning that touch on the short-term and or long-term effects to the environment of hydraulic fracturing?
There are some. The big thing that everybody's waiting on is for the Environmental Protection Agency, but the problem with that is their final report won't be done until 2014. So what we need is to develop a little bit of trust in a lot of the farmers and the rural people who are making these complaints. We can't wait that long to not do anything. As soon as the Duke study was released, the Pennsylvania Department of Environmental Protection immediately went after the gas companies, fined them, and started the process of making the gas companies cover the cost for bringing clean water to some of these people. We just don't want that to happen. We need to regulate smarter. We need to put the proper regulations in place that specify exactly what should be done with the casings. There are treatments that can be done in the wellbore that will enable the cement to adhere better to that surface and to the steel casing. There are several engineers, Dr. Anthony Ingraffia from Cornell, and this is another study that was done, but it relates more to methane emissions. But Dr. Ingraffia, who consulted for the oil and gas industry for many years, has made it very clear that this is a very inexact science. When you're talking about these casings and drilling down so far vertically and then horizontally, it is really hard to expect, when you're dealing with the pressures we're talking about, for those casings to remain solid through that entire distance. It is inevitable that they're going to fail and allow some of these fluids and this gas to get into the water supplies. We have to take every reasonable precaution to make sure that those casing procedures are regulated to the T so that we can at least minimize the chances of water contamination. That's what we're asking. We're not trying to kill the gas industry, but there are regulations that are being fought that are simply in our best interest to prevent this problem that we know is happening. And the well casings are a good place to start.
And I might add that, you know, whenever we drill a well, the protection of groundwater and fresh water, it's first and foremost concern. I mean, the way we drill a well is we'll drill a hole for surface casing. You drill down to below the groundwater, and you set a surface casing in that. That surface casing then is a steel casing that is surrounded with cement. And until that cement is bound to that casing and it protects that groundwater, no further drilling is done. And then once that is, and this is all regulated with a regulator on site. And once that is cemented in and that passes all the regulations, then and only then are you able to drill down deeper and then go on horizontal. And once you get there to the formations that you're wanting to produce from, you surround the casing cement at that point there, further isolating the groundwater, which is thousands of feet above where these producing formations are. So you have multiple layers of protection there that the regulators are on site whenever these cementing and casing setting are on that meet regulations. And industry has done that for years to make sure that groundwater is isolated with multiple layers of casing as well as cement.
Now, I want to mention one of the studies. It's a little different, but this came from Cornell University, and it has to do with the methane emissions. Environmentalists were eagerly supporting natural gas about 6, 7, 8 years ago when they first learned that there was this new supply because there was the potential of reducing the amount of coal power. And coal power in the environmental world is a big bugaboo because it's just loaded with problems. And so environmentalists are really happy to see coal plants shutting down. And there have been a lot of them. A lot of them are on the drawing board, aren't going to make it. So that was good news. They're very encouraged. But then, as environmentalists started learning about, because when you're burning natural gas, when you combust natural gas, it produces about half the CO2 that you get when you're burning coal. So there's a good environmental advantage to that. But then, when environmentalists started learning about the methane emissions, the fugitive methane emissions that were part of the hydraulic fracturing process, they went, uh-oh, I think we got a bit ahead of ourselves here. What happens is that one molecule of fugitive methane, this methane that comes flowing back up and that escapes into the air during the fracking process when there's this flow back and when it's being transported, moved around in pipes and into the storage tanks or the valves and things like that. One molecule of this fugitive methane has the environmental heat trapping damage of about 25 when it's combusted. Methane has about 20 times the heat trapping potential of carbon dioxide. So it's been estimated that if there is just a 2.5% amount of fugitive methane in the entire hydraulic fracturing process, there is no advantage. In fact, it's probably worse than burning coal. What the Cornell study did with Professor Howarth and Graphia was point out in their estimates is that it was likely there is about a 3 to 4% amount of fugitive methane from the fracking process. This wipes out the environmental advantage. So again, we've been going to the gas industry saying, you have to stop this. If there's no real environmental advantage to using gas over coal, this is a zero-sum game. We're going to put humans out of business on this planet. And I want to point out one other thing too, because people, whether or not you believe in climate change, there is a giant insurance company called Munich Re, who they compete with Warren Buffett's group in the reinsurance business. And they produced a study that analyzes the costs of natural disasters since about 1980. And the trend has been like this since 1980. It's going up and up and up and up. Last year was the costliest year in history for natural disasters at $380 billion. Now, whether you believe in climate change or not, when you overlay that graph produced by these business people, this giant company, and their economists and mathematicians, with a graph of the greenhouse gas emissions since 1980, there is an absolute correlation between the greenhouse gases going into the atmosphere and these increasing costs of natural disasters. We have to understand the real risk to our economies, and we talked about the $10 billion in Texas from the heat wave and the $2 billion in lost crops in Kansas. There is a serious economic cost to what is happening to us. If you don't believe in climate change, then you figure out what the cause is. Somehow or another, we should stop it. If we are smart, we're going to start reducing our greenhouse gas emissions and make this quicker transition into renewables. But getting back to this Cornell study now, there are ways of reducing the greenhouse gas emissions in this process. There's one called the green completion, where you capture everything that's coming back up at the drilling site. You capture the fluid, the methane, and everything else. It costs money. Why a lot of the gas industries are resisting it is because the cost of this process costs about as much as what they're selling the gas for now. So it's a huge expense. What we have to figure out is, are we going to allow them to put these costs off to us for these rising costs of natural disasters? All we're asking is that we have protections against these emissions. The technology exists to prevent it. Now we just have to require the gas companies to use these methods that exist.
I might add on something on several things on there. One is the Cornell University study that he referenced there has received intense peer criticism. And when I say that, there's been at least, that I know of, there may be more, at least 11 universities and research groups that have come out and said that this was seriously flawed, including other Cornell University professors. One of the flaws in that is they say the flow back from methane was going to go out into the atmosphere, and what they failed to take into account is that 80 to 90% of that flow back methane in that is captured or burned at the site. So that has been there. Now, they came out in January of 2012, the Cornell professor did, and said they used some more new EPA emissions data, and they did. But what they did is they said that they still, the new emissions data still supported their conclusions from their first report. And now, that was not accurate because they did use the new EPA emissions data, but that EPA emissions data was nowhere near the manufactured data that they used in their reports to come up with their conclusions. As a matter of fact, the University of Maryland did a study of the Cornell study, and their conclusion of it was that it was largely unjustified. And so, you know, that Cornell University study has been actually, many groups out there as we've heard that as being debunked because there's been so many universities that have actually came out with in the other one or to show that that was seriously flawed. There was another study done by the American Council on Science and Health that came out at the end of December of 2011. And what they did was they wanted to increase the awareness about actual threats to human health so that people, I'm just reading what they said, so that people would not have to worry about things that pose no danger at all. And the number one on the top 10 unfounded health scares was hydraulic fracturing. And the reason they said hydraulic fracturing was because the water contamination from fracking was highly unlikely. And so that's another study out there that that would show that hydraulic fracturing is a safe technique.
I want to just mention, Professors Howarth and Graffia responded to the critics of their study, and the flaw that they pointed out amongst their critics was that the critics were using the amount of methane related to natural gas to produce electricity, and they weren't including the much larger amount of methane that's produced when you're using natural gas for heat. It's about 70% of the natural gas in this country is used for heat generation, and about 30% is used for making electricity. So when you add in that amount of natural gas being used for heat, it completely supports the conclusion reached in the Cornell study.
Well, I would disagree with that because I think the professors were saying from the other universities were saying that they were saying that all of the flowback gas that was from this was being vented to the atmosphere, and we know for a fact that 80 to 90% of that is captured or burned. So I think it was a great overestimate.
Are you shooting for 100% or is 80 to 90% just fine?
Well, 80 to 90% was what they said in their study that industry captured or burned.
Okay, if you have a question, please raise your hand. We have a couple students with mics. We'll go here in the aisle first.
Yes, my name is Bill Bryson. I have a question for Mr. Spease. Mr. Cross mentioned Frack Focus. Have you been on their logs on the website to see Frack Focus and what all it entails? And
Yeah.
if you have, are you aware that the California Sierra Club was one of the cooperators in developing Frack Focus?
Yeah, there's a limited benefit to that. The problem with it is it's just incomplete. The gas companies still aren't required to list the chemicals they consider proprietary. So until we have the complete list of chemicals, if there is contamination in water, there's no way of holding the people responsible who use those chemicals. So we need to have that co-list to protect our farmers and to provide the better information that first responders would need at a site.
The list is the list.
Yeah, it's incomplete. A list can be incomplete, and those lists are incomplete.
Clay, do you have someone there?
Mr. Spease mentioned the hydrologic cycle and, the ongoing drought in Kansas. Doesn't hydraulic fracturing then pose an interesting and ethical issue of using the Agua Aquifer fossil water to then extract fossil fuels? And I would like both of you to please comment on that.
Well, I certainly think this is a big concern. My whole family history is with farming. I'm very sympathetic to farmers. So I really want our legislature to be very careful when they're looking at whatever legislation they are going to create related to regulating this technology. Water use has to be at the top of the list. We have to be able to monitor specifically, and there are ways of doing this electronically, so you can monitor the amount of water being used, what's produced, and it's treated. It's a pretty complex process, and we need to be very thorough to protect the future of our farming in this state.
Yeah, and I might add that we as an industry would agree that public safety is always first on water use, but in a drought that comes first always. And how other industrial uses are that we're going to use water for, we just have to look at how we're going to prioritize those. I know from the oil and gas industry there are a number of folks out there that are working to try to reduce the amount of water used in hydraulic fracturing jobs because that would definitely help that. Also working on methods to being able to recycle water that is used so that it can be used again. And so there's a number of things going on out there to try to reduce the water and also help in a drought situation.
I want to mention one other thing related to that. The Kansas Farmers Union has suggested that there be a moratorium on fracking in Kansas until more study is done and more contemplation of regulations has been done.
Stacy, right there you have it.
I would like to know if there are any maximum contaminant level standards type of limits to these chemicals they use for fracking. And I would imagine, since the ingredients and concentrations are considered confidential, they may not be. Are there any, and what do you think about having some minimum standards on water quality for protection?
Yeah, I'll begin now. Okay. The chemicals used in fracturing, as you said, there's a number of chemicals. I don't know, Joe, you may have said there was thousands of chemicals, and there probably are, but not all of those chemicals are used in every frac job. they would have a combination of chemicals that they would use. Many of the chemicals that are in there are detergents. For example, when they're pumping that water and sand down the well, they want to make sure that that reduces friction, so they reduce the pressure. They may have something called GAR, a gel, often found in ice cream. Because whenever you put the sand in the water, you want something to sequester that sand or to keep that sand in suspension in that water, so that when the sand gets to the formation, it goes in evenly. And so there's a number of reasons. They have other chemicals in there that are like in household cleaners that you would have. So it's not chemicals that are uncommon. What it really is just a matter of how much of individual chemical they may use on a well, depending upon the geological conditions that are found in that particular well.
I don't think we're going to come up with any limit. The gas industry has been very successful at convincing Congress that they have to tailor their fluid to the needs of the geologic formation. So what I think we have to do is go back to the casings issue. We want to encourage the industry to come up with the fluids that they tell us can be produced without these texticals that are completely non-toxic. We want to move in that direction, and for the time being, we're probably just going to have to tolerate the numbers of chemicals that are used that they consider essential to effective production at these sites.
Clay, do you have a question there?
I haven't heard a very convincing argument yet as to why hydraulic fracturing wouldn't in some way help contribute to the destabilization of the Earth's surface and contribute somehow in the future to potential earthquakes or earth movement. Do you have any kind of a convincing argument as to why this would not be a potential future problem?
I'll start. I'll start. I'm assuming that question was to both of us. Can I answer it? I'm assuming. Okay. You know, the seismicity and hydraulic fracturing is something I think of everybody's concern. You know, there's been some earthquakes in the East Coast, in Ohio, and even in Oklahoma. And you know, major earthquakes occur along major fault lines. And many times you'll have minor earthquakes where there's some minor fault lines. That also happens to be sometimes where you find oil and gas production. As a matter of fact, sometimes it's the faulting itself that creates the traps that the oil and gas is found in. So, you know, but when you look at the characteristics of earthquakes in areas where there's oil and gas production, and they also look at those quakes that were there before oil and gas production, it's difficult to determine, you know, if there's any characteristics that are different. And so, in our minds, what it is right now, you know, what I'm going to conclude with is there needs to be more study. But right now, it's difficult to determine with any high degree level of certainty whether hydraulic fracturing would cause an earthquake or not. You know, many of them would say that that's highly unlikely, but the bottom line is, you know, there needs to be more study on that, and I think we need to give time for people to study that longer. I don't know how convincing of an argument that is, but that's as honest as I can be. I'm sorry?
It's not a very convincing argument.
Yeah, well, that's as honest as I can be right now with that, you know, with that.
I want to comment on that. There's a man that I consult with in my business, and he's one of the top geophysicists in the country. He's Dr. Stephen Bauer, and works for Sandia National Laboratories. And we had lunch just a couple of months ago down in New Mexico, and this subject came up because I thought if anyone would understand what's going on, he would. And we got into detail about this. And he said, you know what, he had experience with this on a project he was working on in Colorado years ago. And what is happening, what is creating these earthquakes, keep in mind that in Arkansas, not known for its earthquakes, they had more earthquakes in 1 year in 2010 in these fracking areas than they had in the previous 100 years combined. And Dr. Bauer said there is no doubt that it's the injection well problem where you're putting in these fluids, these slick, greasy fluids underground that is the cause of these earthquakes. And I want to point this out because in Kansas, this is an issue. And I've talked to some of our legislators about this, and some of them this is how I get labeled an extremist, because they look at me like I'm crazy, but this is a serious problem. In Kansas, if you look at where our injection wells are located, in the central part of the state, if we have earthquakes anywhere around in here, we have a nuclear plant in Kansas, and all it's going to take is a minor tremor. If you understand how they store their spent fuel, it's highly radioactive. If you understand how it's being stored in these cylinders, all they have to do is shift and topple a little bit, and you're going to have a release of radiation into the atmosphere. And if you look at the prevailing winds in Kansas from the southwest, that radiation is going to be blowing right toward us. And I said, we just need to be sensible here. We need to monitor what's going on in these injection wells. We need pressure testing. We need all kinds of things done so we can prevent a real serious catastrophe as a result of the earthquakes that are definitely connected to the injection wells used in the hydraulic fracturing process. We just need to be careful about this.
Can I add one other thing? The injection wells and disposal wells is certainly, like I say, is separate from hydraulic fracturing. And so, you know, I was talking about the hydraulic fracturing itself. He was talking about injection and disposal wells. So that's a different operation that's covered by a whole different set of regulations. And indeed, there may be some studies needs to be done on injection wells. Also in Arkansas, that was definitely a major fault area. That's a New Madrid seismic zone, which is a major fault that is in that area that would cause some major earthquakes. But yeah, that possibly could be studied too as disposal and injection wells.
My question is, what are the potential health risks involved if fracking is in fact contaminating our water?
I can't hear you.
What are the potential health risks involved if fracking is in fact contaminating our water?
I'll start. I can start. I can just tell you what a study from the one I mentioned a while ago, the American ACHS, you know, that had the top 10 hydraulic health scares. When they looked at, for example, if you actually had a well that was regulated with the Safe Drinking Water Act because you were using diesel in your frac fluid, which that would be under a separate set of regulations. Some would say, well, there's some benzene in that. And so what this study said was the carcinogenic effects of benzene, whenever they're studied, are studied by over long-term exposure at high, or long-term exposure with high exposures, high levels of exposure. And that would have very little to do with the trace amounts that would be found in frac fluids, much less a hypothetical situation in which somehow frac fluids got into the groundwater. And so that's one of the reasons that they would say that was impossible to get there, and it would have very little effect. Now, that's just what that study said. I don't know about the other chemicals. I'm sorry, I don't know what the answer is to that.
I say don't underestimate the dangers from just the methane contamination. And what the Duke University scientists said, too, was, look, if it's possible for this thermogenic methane to get there, it's very possible that the fluids will be getting in there somewhere, too. We've already found evidence in some cases of some of the specific chemicals used in the process, especially 2-buto-oxyethanol getting into water. But the methane itself can be a serious problem. Health and Human Services, the Agency for Toxic Substances and Disease Registration, has produced the information to determine the effects of being exposed to varying levels of methane. It starts with headaches, then nausea and memory loss and confusion and cancer, and you can suffocate. It just depends on the concentration level. There are some people whose water got so contaminated they couldn't shower. They were passing out in their showers from the methane that was coming through with the water. Now, you have to expect some of these people have been on their farms for generations. So we can't expect that they've been passing out in their showers. You know, it's kind of odd that shortly after the fracking starts, all of a sudden they're having these problems. But the methane is a problem that shouldn't be minimized.
Stacy.
I have a daughter that lives in Erie, Colorado, on the Front Range, about 10 miles east of Boulder. And in Colorado, at least, the oil and gas producers have decided that it's okay to drill in populated areas. And in her little housing development, there are like 6 gas wells. They are drilling a gas well now about 100 yards away from a new grade school. They have been able to show that methane levels in the air are excessively high, higher than LA. And she says they have open ponds of frac fluid that are evaporating into the air. I guess the question is, would either one of you be uncomfortable having a gas well in your backyard?
Or for your grandchildren?
Well, yeah, absolutely. This is what I've recommended to the state legislature, that they just completely do away with those holding ponds. What makes volatile organic compounds volatile is they react to just air temperature, and all this stuff, the toluene, xylene, acetone, all these really dangerous things just evaporate and get into the air, and that's what people around those ponds are being exposed to. So that's just a real death wish, being located any place close to those things.
Yeah, and I would answer that. I don't know about Colorado, so I can't address that specifically. But in Kansas, I know that you know, many of the chemicals that are used in the frac jobs are not toluene or all of that. They're things that you would find, like I said, guard gum or household cleaners or something like that. Most of it sand and water. You know, so most of the time the frac fluid then is disposed of in injection wells according to regulations in Kansas. I can't address the Colorado situation.
So the answer is no, you wouldn't mind
Oh,
in your backyard?
no, I wouldn't mind it at all, no.
Especially if you owned it.
Yeah.
Sir, if you could wait for a microphone to come to you.
I think I can talk loud enough without the microphone.
All right, what's your question, sir?
At my age, I speak loudly. I noticed Mr. Spease is in the wind, solar, and hydrogen projects in Kansas City. I happen to be a petroleum geologist, so I've been involved in oil and gas. And I noticed that in the last 2 years, because of fracturing and new technology, that solar wind is probably going to drop to the bottom level in availability in the United States, because we have so much gas, we won't need your solar or your wind power. That's number one. Number two is that I was taught by my parents, when I came in the house, I took off my hat. I noticed you haven't taken yours off.
I'm being considerate because of the glare issue, bud.
Hey.
Better without it than
Thank you for your comments, sir. Sir, we really would like you to ask a question.
I graduated from the University of Kansas in petroleum geology in 1954, probably before you were born. I went to work for Dole Incorporated in Great Bend, Kansas, and you know what we were doing? We were fracking wells. We were fracking wells at Medicine Lodge. We fracked one a day, and there were 10,000-gallon frac jobs, and we mixed the fluid by hand. We stirred it by hand in the top of tanks. And the fluid, you talk about all the chemicals and all the bad chemicals and everything, that's baloney.
Sir, do you have a question?
You're baloney. And the reason it's baloney,
Do you have a question, or would you like to make a speech, sir?
and breathe it every day. No, I'm telling him something.
Okay, but sir, do you have a question? Just you, sir. If you don't have a question, we'd like to allow the rest of the audience to ask their questions.
I want to respond to his question. He was talking about the price of electricity. I want to make sure that all of you understand one thing. Kansas has one of the best wind resources on the planet. and the cost of electricity from wind in Kansas, and now, and this is not me, this is Department of Energy, Lawrence Berkeley National Laboratories, you can go to any of the independent people who have been examining the cost of electricity. The cost of wind power from Kansas is as cheap as any electricity produced from any generating source anywhere. If we have a brain in our head, we will take advantage of the wind resource we have in Kansas to create about 80,000 megawatts of wind power that we'll export to states around us. It'll create about 100,000 jobs here. Since the cost of wind never changes, it will remain at this level. The jobs created by wind power are here forever because the wind doesn't stop blowing. Jobs created through a fossil fuel are here and then they're gone. If we're smart, we will develop wind power, take advantage of energy storage to make it baseload or intermediate power so it's there whenever we need it. It's cheap, clean, creates more jobs, and will stabilize our economy like we have never known in this country.
Okay. I would add, I'm not going to talk about wind power, but I am going to talk about the oil and gas industry. And one of the things that we have in this state is an industry that has been very supportive of jobs. I mean, we have the oil and gas industry in Kansas supports 68,000 jobs, $2.7 billion in family income. It's a $4.8 billion industry. Whenever you look at our industry, 5 of the last 6 years, our oil production in the state has gone up. That's a remarkable story. That's even before any horizontal drilling. What that means is that there's a lot of drilling going on in Kansas. Whenever you look at the oil and gas industry, we invested $1 billion for the last 5 years into rural Kansas. There's few industries that will invest $1 billion a year into rural Kansas. And so the oil and gas industry is a stable and dependable element of the Kansas economy and will be so for many years.
I'm sorry, if you don't get a chance to ask your question during the Q&A session, we will, you can come up and talk to our panelists after the discussion. We have a time for just one more question. Clay, do you have a question back there?
First of all, Mr. Cross, Mr. Spease, I'd just like to say, like, as a citizen, I really appreciate the fact that you guys are taking the time out of your very educated and prolific careers to have open discourse and communication in front of a public forum, because I think this debate is the right one. So I just want to say thank you, first of all, before I get to my question. Mr. Cross, specifically I have a question for you, sir. The confidence behind your words and behind supporting the Kansas rural community, I think is absolutely admirable. But first, I guess my question is about proliferation, and before I get to that, I have a question about kind of the vertical career that you've had. 30 years, you've said, as a geologist. You've been working in the Kansas area. Is that correct, sir? Ish?
Well, yeah, 26 years. I started in Illinois, and I'm here in Kansas now.
In any of that time, have you ever been surprised by a rock formation? Have you ever hit granite at a different depth than you thought, or found some sort of formation that you were surprised by, 4,000, 5,000 feet below the ground? Because it's so unpredictable and it's such a new science. I was just curious from your expertise if you've ever been surprised from a rock formation 4,000 feet beneath your predicted depth of what you thought was going to happen.
You know, geology is something that is never an exact science, and so that's one of the things about a geology career is that it is exciting because you can drill into a formation that you've seen the rock samples many times before, and you're drilling into another well, and you'll see something a little bit different. And sometimes that's an indication that you're headed in the right direction for oil and gas accumulation. Other times it may not be such a good sign. But there's a lot of heterogeneity, or a lot of differences in those rock formations, in any rock formation that you look at. And that's what we study.
Thank you. Would you say that horizontal drilling just multiplies the complexities to the unknown science?
Well, I think the horizontal drilling is something that goes on. It's unconventional, meaning that instead of looking for the reservoir rock and accumulations of the oil and gas, the reservoir, the source, and the seal are all in one and the same rock. So drilling horizontally through that you don't have to look for the trapping mechanisms. You're just drilling through the rock to where the oil and gas was actually sourced from to begin with.
I know the microphone is taken away from me, but I'll just continue to speak. With the proliferation process, with the horizontal drilling and the complexity fissures within the rock. With the complexities, the ambiguity of that, how can you not support federal regulations that are going to protect people that is 2,000, 3,000, 4,000 feet beneath the surface where we live? As you, as a businessman, wouldn't you want to protect your consumer?
Yes, you know, and I agree. And what I agree with that is I think that the hydraulic fracturing has been well regulated by the states for decades, and it's still today. And what we do is we look at like the Kansas Corporation Commission, and I'll speak to that state because that's where I'm from, is we don't have a section of our regulations that say hydraulic fracturing regulations. But we have hydraulic fracturing regulations spread throughout all of our regulations. They're under casing cement, they're under well design, they're under well spacing, they're under underground injection, they're under waste management. And all of those combined actually protect the fresh water from not only fracturing, but from all oil and gas operations.
Thank you for your time, sir.
If you could join us in thanking these gentlemen for coming out tonight. Thank you all for coming out tonight.